Up next, we're learning about U substitution, or U sub, as everyone calls it. If I spelled that wrong, that's not on me. Anyway, when do you use U sub? You use U sub when you have a problem like this, and you have to find the integral when you got multiple things going on. Kind of like the chain rule, right? You have this and you have this. You have two things going on. How do you integrate this, right? Do you bring this 3 down and then -1 on the exponent and then integrate the inside? No, that doesn't make any sense. You don't do that. What you do is you make it real easy. You take this right here and you go, I don't want to deal with that. So you create a variable called u and you make it 4x plus 3. Now, if u equals 4x plus 3, and we're trying to integrate this, we can make it integral, u to the third power dx. See what I'm saying? But problem is, we have a u and we have a dx, and those are not the same variable. So what you have to find is du. And how can we do that? You derive this function here, and you'll end up with du over dx on the left side equals 4. Are we following? And then you multiply both sides by dx to get this dx out of here. So you end up with du equals 4 dx. And then you divide both sides by 4 to get the dx on its own. So you get du over 4 equals dx. See how that works? We derive this. We get du over dx because we're deriving in respect to x. And then we get the du on its own by moving the dx over and moving the 4 back. So now, this dx over here, you could get rid of it. And we could put in our du over 4 because du over 4 is the same thing as dx, so they're interchangeable. Now that we have this is the same thing as writing u to the third times 1 over 4 du, right? Because anytime you're multiplying, you can do it in any kind of order. So we're going to bring this 1 over 4 out to the front and integrate u to the third du. And now it's just normal integration, right? So we have u cubed, so we're going to add 1 to the exponent. We're going to get u 4 over 4, and we're going to multiply it by our 1 over 4 that we have, and we're going to get u 4 over 16. Now we're almost done, but remember, u equals 4x plus 3, right? So all we're going to do is switch our u back with 4x plus 3, and we'll end up with 4x plus 3 to the 4th power over 16. And then, of course, it's integration, and do you see a number here? Do you see a number here? No, you don't. That means you have to add a plus c at the end, and this is going to be our answer. It's a little bit messy. Let me erase the 16 to make this very, very clear. So this down here is going to be our answer. We'll look at a few more of these, and we'll get more and more complicated as we go. How about this one? We got multiple things going on. We got something raised to the power 3. We got something being multiplied. How do we integrate this? We u sub. So in this case, we're going to make this one u because it's the most cringe. Normally, that's how it works. The one that you want to deal with the least just works if you put it as u. So we'll go u equals 2x cubed plus 8. Again, we're going to derive this to get du. We're going to du over dx equals 6x squared. Du equals 6x squared dx. And then du over 6x squared equals dx. Y'all could kind of see that, like, these two steps here are a little bit like redundant, unnecessary. How I look at this, I just see, okay, you derive this function, you get 6x. Whatever the derivative is going to end up underneath du. So what I do is if I were to solve this problem, I'll go u equals 2x third plus 8. And then I would just derive this, so du over the derivative, which is 6x squared, equals dx. This is how I think about it. If you want to skip these steps, you can, and just derive this and put it under the u. That's what I do. But if you want to write it out because it helps, or because what I just did doesn't make any sense, that's cool too. So now that we have our du, then you can rewrite this as 3x squared times u to the third power du over 6x squared. And now you could be looking at this like, oh my god, you did all that and you still have this crazy equation that I don't know how to solve. Look, check this out, right? We have 3x squared and we have 6x squared on the bottom, right? We have 1 over 6x squared. If you wanted to rewrite this, you could rewrite it as 1 over 6x squared times 3x squared times u to the third du. If you just look at these first two terms, you can see that this fraction would cancel out this 3x squared. So you'd be left with 3x squared over 6x squared. And what is this? It's the same as 1 over 2. Because these x squares are canceling, and this 3 and the 6 is divided by 3. You're going to get 1 over 2. So this equation here, this 6x squared and this 3x squared are going to cancel. And you're going to end up with 1 over 2 u to the third power du. You can move the 1 over 2 out. And you're just left with u to the third power du. Then you integrate this like you normally would. U to the fourth power over 4 times 1 over 2, right? So you're going to end up with u to the fourth power over 8. And then you could plug our u back in because our u equals 2x cubed plus 8. So you end up with 2x cubed plus 8 to the power of 4 over 8. And again, do you see a number here? Do you see a number here? No, you don't. So we're going to add a plus c at the end. Let's look at some definite integrals, the fun kind with the numbers on them, right? So how would you solve this? Again, you're looking at this, you're like, I don't know how to do this. Too many things going on, square root, other thing, right? Also, it's DZ now. Doesn't matter what letter you use as long as it's the same the whole time. Variables are variables. So look at this, think, what is the most cranks? You could also think what's going to cancel out because we have to cancel something out. If you noticed, last time we canceled out the 3x squared. This time you can see, okay, we're going to cancel out this z. So that means we have to derive this part. So we have to create our variable. We have to say u equals z squared plus 4, right? So that means that du over dz, because you're deriving in respect to z, it's going to equal 2z. And then you have your du equals 2z dz. And then du over 2z equals dz. So now we can plug in our u and our du over dz, right? But can we? Look, so you have this 3, and you have this 0. When you're doing definite integrals, you have two options. You could either integrate the whole thing and plug these numbers back in like we've been doing, and then solve it with the 3 and the 0. The other option is you change this 3 and the 0 for your u right now, and then you won't have to go back and do it later. So I'll show you both ways of how to do it. The first one, I'm gonna change these numbers out for this u because that's how I like to do it. So if we plug 3 and 0 into this equation, we have to see what they would turn into. So if we plug 3 in, we get 3 squared plus 4, which is 9 plus 4, we get 13. So we would end up with 13 on top, and 0, if we plug 0 into our u equation, we'll get 0 plus 4, we'll end up with 4. So we could go from 4 to 13. So now we can just rewrite this equation as z square root u du over 2z, right? And we can keep it as u for the entire rest of the equation, and we never have to change it back. Then we cancel out these z's, and you're left with 1 over 2, 4, 13, square root u du. And then we solve this like we normally would. U 1 over 2 turns into u to the 3 over 2 over 3 over 2, or 2u to the power 3 over 2 over 3. And we have to multiply it by our 1 over 2, so we'll end up with 2u 3 over 2 over 6. With our two numbers 13 and 4. Now that we have our equation and our bounds, we could write this out. 2 over 6 is the same thing as 1 over 3, so I'm going to write it as 1 over 3 from now on. We could plug in 13 and 4 as our u. So we have 1 over 3, 13 to the power of 3 over 2 minus 1 over 3 times 4 to the power of 3 over 2. We can simplify this more. 13 to the power of 3 over 2, you can just leave as square root 13 power 3 over 3 minus 4 to the power of 3 over 2 is 8 over 3. You can combine these, you get square root 13 to the third power minus 8 all over 3. And this would be your solution. Now let's look at the other way to solve this problem. The second way to solve this problem would be to write it out and keep this 3 and the 0 the same. So we'll go integral from 0 to 3 of z square root u du over 2z. These z's will cancel out, and we're left with 1 over integral from 0 to 3 u to the power of 1 over 2. Then we would do the same steps as before. U to the power 1 over 2 would turn into 2u to the power of 3 over 2 over 3, and we would have our 3 and our 0. Then we would turn u, since we kept this 3 and we kept the 0, we'd have to turn u back into this part up here. It's z squared plus 4. So we end up with 2 times z squared plus 4 to the power of 3 over 2 over 3. And we would plug in our 3 and our 0, and we would get the same solution we already got. So either way works. It's really just preference. I prefer solving them early so I don't have to go back, because a lot of the times I forget to switch the U out with our original U. So I like to switch them early so I don't forget. That's going to be it for U sub. So we moving on.